Bam! Mr. Tarrou, in this lesson we're going to take a look at not one, not two, and well, you could say 3 examples, but I'm going to do each of these examples 2 different ways. So you could even argue maybe I'm going to give you 6 examples of dealing with problems involving percent of increase and decrease. Your textbook might also call these just simply percent of change. And there's 2 ways to approach these problems. You can write an equation for each of these, and sometimes I prefer this method. It's the original amount plus or minus a percent of change times the original amount. Is going to be your new value. Perfect example of this, and this is dealing with, buying something at a store, but just verbally real quick. If I bought something for $3 and the sales tax in my area is 7%, then that $3 item is going to have 7% of that original $3 added to it. So 0.07 times 3 is 21 cents, and so $3 plus 21 cents would give my new total bill of $3.21. So that's just that's really what they do at registers every time you buy something that is charged. They charge tax to. Now another way of working with percent problems is with equal proportions. Part over whole is equal to percent over 100. We used this method in our previous just basic introduction to percents, and we rewrote it a little bit as is over of is equal to percent over 100. But that rewording of this formula is only good when your percent problems are very short, almost phrase type questions dealing with percent, like 17% of what is equal to 33. Okay, so let's start off with this first problem here. An item is priced at $240 and it's decreased by 20%. If the sales is 7%, how much will you pay? Well, there's 2% of change here, and you do need to deal with those in 2 separate steps. You can't look at this and say, oh, well, the item is decreased by 20% and then marked up 7% because of the tax, so there's a net decrease of 13%. It doesn't work that way. I'll show you how that answer is going to be incorrect when this problem is done by simply applying a 13% discount. Okay, but let's do it correctly the first couple of times, because I'm going to do this 2 different ways, of applying that 20% decrease. And I'm going to use this formula up here where it's actually written out as an equation. So my original value is $240. We're going to subtract out 20% of that price, and so it's going to be the percent of change. We need to move that decimal. We don't really like to work with percents in percent sort of format. That's only appropriate when you're using this part over whole is equal to percent over 100, because like I said in the previous lesson, that division of 100 is going to automatically sort of move that decimal for us. We don't have to. But when you're working with percents in any other type of equation format, you need to move that decimal over. So I've taken the 20% and moved the decimal to the left 2 places, and then it's of, that means multiplication, 20% of the price, which is $240. And then that is going to equal, well, whatever my new price is after the discount. I don't know what that is. That's why we're doing the problem. So we have 240.00. You may want to just write 240 as well, because these are just zeros, 2 zeros to the right of the decimal. You can keep those there as well, because this question is about money, and we have sort of like a natural 2 decimal system situation going with the fact that we have 100 pennies in every $1. So I'm going to keep them in here. So we have 240 minus, now 0.20 times 240 is going to be 4,800. That's what you would get if you hadn't moved the decimal to the left 2 places with the 20% like you should have, because 2 times 24 is 48. But now when you look at this, that's 0.20. We have, it's sort of like basically 2 decimal places in here moved over, so we need to move that decimal over here 2 places and really realize that 0.2 times, or 0.20 times 240 is 48, not 4,800. And of course, this is a discount, so that's going to reduce the price. So just keeping the 2 zeros there because we're dealing with money. 240 minus 48. Well, 240 minus 40, just looking at the tens place, is 200. Minus 8 is 192. And that's the new cost of the item after the 20% discount has been applied. And now they're going to, now that that has been done, we're going to add in that sales tax. Now we're going to bring the price back up a little bit by 7%. So it's going to be my sort of new original price, if you will, $192. And just to give a different look, I'm going to go ahead and, well, now let's keep those zeros there. Plus 0.07 times 192.00. This is going to be the new cost, the total price after the discount is applied and the taxes have been increased. Now, I'm not going to try and do that in my head, but I do need the right page here. We got 0.07 times 192 comes out to be, right off the top of my head, $13.44. So we have 192 plus 1344, and that is going to be 192 plus 10 is 202, and 202 plus 3 is 205, and now it's 205. Let's not put the decimal in the wrong spot. $205.44. This is my total. This is what I'm going to have to pay at the register after that 20% discount and the increase of 7%. Okay, now I'm going to step off. I'm going to do two things. First, I'm going to do, I'm just going to write down here in orange or red. I'm going to write down what the answer would be if I had just tried to do this in one step and make a 13% discount, right? Because that was a 20% off and then 7% added, and show you how the number is going to be different. And then I'm also going to reveal step by step another another way of doing this problem. This is probably how your teacher is going to teach it. This is how I would teach to do the problem the first time around, but you know, growing up, like my mom was a waitress before, you know, everything was computerized, and she had some tips to more quickly figure out, you know, what the total bill would be, just because all she really needed was the total. She didn't need to see the tax separate and then the total for the bill. So I'm going to kind of just give you some different ways, maybe a little bit shorter ways to do the problem that may or may not give you exactly what you need. That depends on your teacher and what is in the problem. Bam! An alternative method. Oh, and did you notice, I don't know why I'm pointing, I have erased it now, but the price of the item was different had you just tried to apply a 13% discount. So hopefully you got to realize you got to do this in 2 steps, or as many steps as percents of change you are given. So if you go, okay, well, no one's going to walk up to the store and go, hey, let me get part of that bill for you and give you a 20. No, it's either there's a part of it that's going to get marked off by the discount and a part that you're going to pay. Well, those two parts have to add up to 100% of the bill, right? No one's going to pay a piece. No stranger's going to come up and just hand you a 5 and pay for part of that bill. It's those two. They're called actually complementary events, if you want to look that up. But at any rate, if it's 20% off, you're paying the other 80%. So you can just simply do 1 minus 0.2, you could do 100 minus 20% as well, and go, well, that's 80% I'm paying. Change that to a percent and do 240 times 192. And now that, 1 times 20, 100, let's try that again, 100% times 20% is 80%. You multiply that to the 240, the original price, and what is left is what you're paying, which is $192. And now, that 192, if I don't really need that tax value as a separate number, you do want it on your receipt. But if you just want the total bill and you want to get straight to the total bill, you can do 1 plus 0.07 and thus multiply by 1.07, and you get right to that final answer that we got before of 205.44. Now, why is that working? Well, the 1, like up here, the 1 representing 100%, it's just 100% written as a decimal is 1. The 1 maintains the 100% of the original amount, and the 0.07 is going to add the 7% tax, and in one multiplication, instead of a couple of steps, you get the final price. But again, you don't see the tax amount, which I think was $13.44. Now this looks quite a bit different. You might like it because it's less writing. And what I want to just emphasize here, it's got the same mathematical foundations as the previous problem. If you look up here, we got 240 times 1 minus 0.2. Again, that if it's 20% off, you're paying the 80% that's left. Well, if you look at it how I had in the original way that I worked out the problem, if you've maybe hopefully been taught how to add like terms this way, when you add to like terms like 2x plus, I don't know, 5x, a lot of textbooks will show you how that each of these terms both have a common factor of x, and so you can factor that monomial, that x, out and write it as 2 plus 5 times x, which is 7x. Okay, well that's what's happening here. This 240 is kind of like our x, except that we know what that number is as opposed to a variable, which is still a number, we just don't know what it is. This 240 has a multiplication of 0.2 or negative 0.2 to it. This 240 has a multiplication of 1, and each of these terms, their terms are separated by addition and subtraction, have a factor of 240. So I can undistribute that 240 if you haven't become comfortable with the term of factoring yet. I can undistribute the 240 and pull that 240 out of each of those terms and write 1 minus 0.2, which is the same line that I started up here with my quote-unquote alternative method or look of solving this equation or this problem, but has the same mathematical foundations as the first way I solved the problem. Next example. Bam! Example number 2. A store purchases an item for $38 and then sells it for $80. What is the percent of profit? Well, you might not know what profit means. So profit is the net income, how much the company makes after subtracting the cost of the item from what they sold it for. So in this case, if they sold it for $80 but bought it for $38, they made what looks like is going to be $42 on the item. Now, this is a simplified sort of Algebra 1, right? Version of this type of problem. Real businesses, they have to pay for the building, they have to pay for the employees, they have to pay for utilities, they have to pay for insurance, they got to pay for all kinds of things, taxes, but we're just going to be looking at the original cost of the item. Now we're going to do this again 2 different ways, one way with the equation, one way with the cross multiplication setting, and I want to do that first with this one. So part over whole is percent over 100. Now putting that sort of very general setup into this real life setting here, when you're doing these cross multiplication setups, the numerators have to represent the same type of variable. One's going to be a value, one's going to be percent, but in this case, it's going to be about profit. So if we're looking for a percent of profit, then the numerator on the other side, the part, is going to have to be the actual amount of profit. And the whole is going to be the original amount. Excellent. Okay, so our profit is going to be, even though I verbally said it already, the price that they sold it for minus the price that they paid for it, the store, which was $38. Now 80 minus 30 is going to be 50, and 50 minus 8 is going to be 42. Now when I do addition and subtraction and multiplication on paper, I will go right to left and then do the whole carry and bar over type situation, but when I'm doing it verbally in front of the camera in my class, as much as I can, I work in the opposite direction so I don't have to do any carryovers or borrowing. So that's how I got the $42. So the amount of profit is 42. You can keep the dollar sign in there or not, it's up to you, as long as you understand, what's about money, what's about percent in the context of the problem when you're finished. It's unknown, it's an unknown percent of profit over 100, and the original price of the item, it's not always going to be the larger value. It's going to be, you have to reread the problem. It started at 38, the cost, to the store before they marked it up. Did I just say that right? $38, right? Okay, now when you're going to solve that, when you have equal proportions or one fraction on the left of the side of the equation and one fraction on the right, you're going to do those problems with cross multiplication. Okay, one fraction equals one fraction. I don't care how simple or complicated it looks, you can do it with cross multiplication, with equations anyway, and then do that part that has the variables. So 38x, 42 times 100, of course, is 4200. We're going to undo that multiplication of 38 by dividing by 38. And our final answer, right off the top of my head, not really, 4200 divided by 38 is 110.5. 0.5 what? What was x? X was the unknown profit. Okay, it's a percent. So it's 110.5% profit. Now, I'm not moving the decimal. Okay, I'm not going to move it to the right two places and say it's like, I don't know, 11,000% profit, because when I'm doing part over whole as percent over 100 again, I don't need to move the percent. I just need to recognize that I was looking for an unknown percent and just tack that onto my final answer. In word problems, you need to put that number in context of the setting. Okay, I'm going to step off. I'm going to reveal another way of doing this problem, same setting. I'm not going to explain my way through it. I'm going to do that when I'm done, and I'm going to do the problem with that equation. The original plus or minus a percent of change times the original amount is going to be equal to the new value. See if you can't pause the video and set that up on your own before you see my solution, and then I'll come back and, of course, explain it. Bam! Okay, well, going back to that percent or that original value plus or minus the percent of change times the original value gives you the new value. So we have the original cost again is $38. We're going to add, because we're marking the value of the item up by a certain amount, a percent times 38%. Or excuse me, let's try that again. $38 plus a certain percent of that $38 is going to be our markup. And I said markup, percent of markup in the previous video as well. I looked that up, and I put an overlay on the video about how an explanation of percent of profit, which didn't quite jive with my percent of markup. I saw percent of markup written up different ways, explained different ways on the internet, and that does lead to some confusion with percent problems. It's the language that's incorporated into the problem. I mean, is it in the percent of change reference to the store, the customer? It's a little bit different if you mark things up or down. So I'm kind of wishing almost I didn't say that you use that verbiage of percent of markup in the previous video like I did. But at any rate, it's $38. We marked it up, that $38, we multiplied it by a certain percent to find out how much we were going to increase the value of the item by. We got to $80. We're subtracting both sides by 38 and getting $42. We're now saying, okay, I have to continue solving for P, the percent of profit. I put P for profit this time. It, again, could be for price as well. And when you really, I should have said, that P equals profit. It is always a good idea with word problems when you do your work to define the variables you're using, because someone else could show the work differently, but the way they have the variable defined is their work is correct for that definition. So P is profit. Okay, so we're going to have now 38P is equal to 42. We're going to divide away the 38 to undo that multiplication. And we have P, that profit, is going to be 1.105, but now that's just a decimal version of the percent of profit. So now we have to multiply it by 100 to get to that actual value of 110.5% profit. Now if you look right here for just a second, and I go back to the first method of, if you want to call it that, it's really more of an appearance of how I solved this problem. 42 over 38 was equal to, let's try that again, x over 100, and it was part over whole is equal to percent over 100. You see how I'm really getting, I've started off with an equation, if you will, a method of solving these problems. It really looks completely different, but I still got to that 42 over 38 is equal to now I'm showing this x over 100, and again I talked about that when you do part over whole as percent over 100, how you don't have to think about moving the decimal, which I had to do for this problem because of how I started off the problem with that sort of equation type setting. But again, I just want to show you that all of this is related, and this looks completely different than the other method, but really ultimately somewhere in there it's all the same process, just a different look and feel to it. But again, the final answer is 110.5% profit. We got one more example, but I'm going to do that as well, two different ways. It's the last example. You go out for dinner, and after leaving an 18% tip, the service was pretty good, you tip the server. The bill is $37.40. How much was the bill before the tip? Now before you go, that's a lot of tip. Waiters and waitresses in the US, they only make a couple dollars an hour, not the normal minimum wage of, I'm not sure what it is right now, honestly, maybe about $8 an hour. They work basically just on those tips. That's the vast majority of their earnings. So if they're good, leave them a tip. Even if they're not great, leave them a tip. They don't make hardly anything. Okay, so at any rate, this kind of question is a lot less common and is definitely more confusing for students to figure out at first because you don't know the original amount. Okay, now so before we figure out or think of, well, how could we do this? You know, could we just take 18% of $37.50 and subtract that down? No. Before we finish this problem, and going back to the very first question in this video where I said you couldn't take the 20% off and add on the 7%, let's just think about something like, let's say that something costs $100 and I mark that off 50%. If I mark that off 50%, now I'm picking this because hopefully we understand that 50% of something is half of something. So if I subtract this by 50%, so 50% as a decimal is 0.5, we're going to get $50. So if something is worth $100 and you mark it down 50%, you're now at 50. Now if I take that 50 and I think, okay, well, if I mark something down 50% to get to 50, I should be able to mark it up 50% and get back to the original price because the mark down 50% and the mark up 50%, that's the same number. But 50%, well, if I take 50 and I add, again, 50% is 0.5, I'm adding 50% of 50. Well, 50% of something is half, so I'm really only doing 50 plus 25, which is 75. Indeed, if something is 100, you lose or mark off half of that value and you're down to 50, I would have to take 50 and add another 50, that whole value, to get back up to 100%. I would actually have to mark up or add 100% to the 50 to get back to the original 100. Because, again, the definition of percent is per 100, okay? It's a part of, and, you know, per 100, if you have 100 of something, each per has got a value of $1, if you will. And if you only have 50 and it's per 100, then per every one of these 50, that's only 50 cents. I'm not sure if that's verbiage now is going to confuse you or help clear things up, but point is 50% of 100 is a different value than 50% of only 50. Thus, it doesn't just, you have to recalculate those percents of change one little step at a time. Because while the percent of change is the same, if it's being applied to a larger or smaller value, the actual amount of change is going to be different. Okay? So what I'm trying to say here in a long-winded way to maybe clarify things for you a little bit, I can't just take $37.50 and subtract 18% because that's a larger value than what the bill was originally. So if I were to take 18% off of $37.50, I would actually get below what the bill actually was. Because we're taking, really, how does this work? You have a small bill and you add 18% to it. So you're taking 18% of a smaller original value. Okay, so enough talking. Let's get to the work. Do we know what the original price was? No, we don't. What are we doing to it though? We're going to add on a percent of change. And how do we find a percent of change? We're going to take that percent of change and multiply it by whatever that original amount was. Sorry for the sloppy handwriting. So my original bill, again, don't know what it is, but to calculate 18% of it and add that tip, I would be doing 0.18, that 18% is a decimal, times that unknown value, and getting the final value, the new value, the total price that you paid for your dinner, including tip, of $37.50. So we have a 1 in front of that x. We're going to add these like terms, which means in like terms, same variable, same exponent. So it's going to be 1 plus 0.18 is going to be 1.18x is equal to 37.50. Divide both sides by 1.818. And x is going to be equal to, I'm going to put the dollar sign back in to put it in context of this problem, let's see here. Looking at the right spot. Yes, $31.78 is how much your original bill was. Should just write slower. Probably take the same amount of time anyway. As the original, that's the $31.78 is the original cost of the meal before the tip. How can you do this problem with the cross multiplication design again? Let's see that before we finish the video. Now honestly, I probably would not work out the problem this way. This is the only type of question where you're given, again, that final value and you're looking for the original price before the percent of change. These are the only ones I really don't like working with this cross multiplication or equal proportion type idea, but I just wanted to give you the look since I did with all the other ones. Part over whole is percent over 100. The part value doesn't really have to be less than the whole value, and we're looking at that 18% increase. So the percent of change or the See, this time I can't really say percent of change because I don't know the change that was added to the original bill, so we have to do it all at once. There was an increase of 118% from the unknown original cost of the meal. So we have the new value, if you will, after that whole 118% has been applied is $37.50 over the original amount. That was the value, the part after that multiplication or that application of the 18% tip and the 1 to hold, again, that original 100% of the original value. Cross multiply, get 118, x is equal to 3,750. You divide by 118 and you get 3178. We had that same 1 plus 18% in our equation. It was the coefficient of our unknown original value in each of these two terms. They had this, again, like terms, so we just sort of undistributed the x, if you will, if your teacher's saying it that way as far as when you add like terms, and I'm just adding the coefficients. So I had that same 1 plus, in this case, 0.18 because my percents were in terms of decimals. So this time, again, there's still relations between these two methods, but when working backwards, I really strongly prefer this method. So that's the end of my third example. I hope you understand percent of increase and decrease problems now. I'm Mr. Tarrou. Bam! Go do your homework.